HOD Professor K.K. Chaturvedi sir, Seminar Coordinator D.P. Sharma sir, faculty members and my all batchmates. My name is Nitish Kumar, currently pursuing my bachelor's degree in mechanical engineering from University Department Rajasthan Technical University. Today I am here in front of you all to present my presentation of my seminar topic is continuously variable transmission under the guidance of Dr. Prajapati sir. Let's start with first slide. These are the topic of my seminar. Basic of transmission. The job of the transmission is to change the speed ratio between the engine and the wheel of the automobile. The transmission uses a range of gear low to high to make more effective more and more engine torque and driving condition change. The gear can engage manually or automatically. This figure shows how transmission connected to the engine and the rear wheel of the vehicle. Engine connected to the clutch and clutch connected to the transmission. The transmission connected to the drive shaft and the drive shaft connected with the differential and the differential connected with the rear wheel. Now, what is continuously variable transmission? A continuously variable transmission is an automatic transmission that can change seamlessly through a continuous range of gear ratio. This contrasts with the other of the gear ratio to construct the other transmission that provide a limited number of gear ratio in fixed state. The flexibility of CVT with suitable control may allow engine operate at constant RPM while vehicle varying speed. CVT is an advanced technology and automatic transmission. Unlike traditional automatic transmission, CVT doesn't have a gearbox with a set of number of gears. It varies the transmission ratio continuously, shift automatically with an infinite number of gear ratio. Working of CVT. CVT consists of two adjustable conical pulleys driven by V-belt. One of the pulleys is driven by engine and the other is coupled with the wheel. The distance between pulleys is inversely proportional to with the velocity ratio of the belt drive. Hence, by adjusting the distance between pulleys, we can obtain desired number of gear ratio without a stepped gear. CVT components. In this diagram shows all the components of that are used in a kind of CVT transmission system, like input pulley, output pulley, high strength steel check, clutch, etc. These are some common types of CVT that is used in an industry. Pulley-based CVT, toroidal or roller-based CVT, hydrostatic CVT, infinite variable transmission, and cone CVT. First, pulley-based CVT. This is the most common CVT system. There are two V-belt pulleys that are split perpendicular to their axis of rotation with a V-belt running between them. As the distance between the pulley and the length of the belt does not change, both pulleys must be adjusted, one bigger and other smaller, simultaneously in order to maintain the proper amount of tension on the belt. Simple CVT combines a centrifugal drive pulley with a spring-loaded driven pulley. After use of tension to affect the conformation adjustment in the driven pulley, the V-belt need to be very stiff in the pulley axle direction in order to make only the short radial movement while sliding in out of the pulley. Belt design. In a steel check, up to 400 steel component transmit power on a single push belt. In a CVT transmission, the push belt transfers the torque from one pulley to the other. The level of power transmission is adapted automatically through continuous variable adjustment of the pulley. Toroidal CVT'S. Toroidal CVT'S are made up of discs and rollers that transmit power the disc instead of the belt and pulley. Toroidal CVT used in the Nissan category Y34. Toroidal CVT as used on a Nissan category Y34 consists of a series of discs and rollers. An advantage of toroidal CVT is the ability to withstand higher torque loads than a pulley-based CVT. In some toroidal system, the direction of thrust can reverse within a CVT, removing the need for an external device to provide a reverse wheel. Hydrostatic CVT. Hydrostatic CVT use a variable displacement pump and a hydraulic motor. All power is transmitted by hydraulic fluid. Compared to gear-based transmission, hydrostatic CVTs are generally more expensive, but on machinery that already utilized hydraulic power transmission, and the added complexity and cost is less significant as with the most hydraulically power transmission. Transmitting high torque for the extended duration required pulling on the hydraulic fluid. Now, infinitely variable transmission. A subset of CVT designs are called infinitely variable transmission (IVT). Some CVTs can also function as infinite variable transmission, which offer an infinite range of low gear. Example, moving a vehicle forward at infinite slow speed. Some IVTs prevent back driving, where the output shaft can freely rotate, like an automotive transmission in neutral, due to providing high back driving torque. Cone CVT. A cone CVT varies the effective gear ratio using one or more rollers. Cone CVT using belt drive can also be used in go-kart vehicle, which poses less load. It can also be used in a small car like Tata Nero electric car and hybrid vehicle. Cone CVT with gear cut and chain drive can be used in Formula 1 car. It can be used in motorbike using chain drive or belt drive. Why we use CVT? The CVT proved 35% more efficient than manual transmission. With same car the engine, the CVT takes only 75% the time to accelerate to 100 km/h compared to the manual transmission. CVT takes only 8.8 seconds to reach 0 to 100 km/h of speed, but manual transmission takes 11.9 seconds to reach 0 to 100 km of speed. Now, application of CVT. It is used in small vehicles like golf cart, motorized wheelchair, heavy earth mover, power tool, industrial equipment, mini machines, etc. Advantages of CVT. There is improved acceleration due to lower power loss, experience stepless transmission, deliver maximum torque, provides a smoother ride than automatic transmission, adapts to varying load, condition and power demand to allow for a better ride. This improves fuel economy and reduces exhaust emission. There are 25% fewer moving parts of the CVT transmission. Disadvantages of CVT. Higher cost. Belt-driven CVT have a limited amount of torque. Transmitting motion by friction causes greater wear. Require special oil and other materials because jerky in automobile applications at slow speed. New technologies show there are limited persons that understand the operation within a CVT. Now I conclude this seminar. Today, only a handful cars worldwide make use of CVT, but the application of and benefit of the continuously variable transmission can only increase based on today's research and development. As automakers continue to develop CVT, more and more vehicle lines will begin to use them as development continues. Fuel efficiency and performance best will inversely increase. This will lead to increased sales of CVT equipped vehicles. Increased sale will prompt further development and implementation, and the cycle will repeat ad infinitum. These are the references where I collect information for completion of this seminar. If you have any question, feel free to ask.
Yes. Which company starts introducing this transmission technology in their vehicles?
Okay. CVT is a Japanese technology. That's why first early 1990s, Nissan introduced this technology in Nissan March. That is Japanese company. After that, in 2004, Ford also being offering this technology in their car. Now, many more companies offering this technology like Kia Motors, Audi, Toyota, and many. Any other query?
No.
Thank you. Have a nice day.